We are working on simple agent-based models. That's agents with models with heterogeneous agents, in particular models with heterogeneous expectations. And then we are testing these models in behavioral laboratory experiments. So that means that in Amsterdam we have a laboratory. We bring subjects to the lab. These subjects are usually students, and we give them an economic task, and then we measure the behavior in the laboratory experiment. And we've done a lot of so-called learning to forecast experiments. And then basically what we do is we bring a standard economic model to the lab. The model has expectations in it, and the subjects in the lab, they form expectations. And then we repeat this experiment for, let's say, 50 periods. And then we can measure individual expectations, and we can also measure the aggregate behavior that comes out of this system. And in that way, we have been able to fit a behavioral theory of expectations to the laboratory data. And one important conclusion that comes out of these experiments is that, in general, rational expectations is not a theory that gives a good description of these laboratory experiments, especially in systems where you have positive feedback. And positive feedback means that when the average forecast goes up, also the average price realization goes up. And that is, for example, a very important feature in financial markets. In financial markets, when investors are optimistic, they buy more stock, price goes up, and that then sort of leads to a self-fulfilling prophecy that we also see in the lab. Yeah, I think to apply complexity theory to policy is very important. We are only starting to do that, but I think it's very important to do policy analysis with complexity models. And for the research we have done, we have found in the laboratory, in these learning to forecast experiments, that rational expectations hypothesis is not a good way of describing expectations of subjects of the private sector. We have found an alternative behavioral theory of expectations that can be quite different from rational expectations. And then it is very important to, if you do policy analysis, to not base the analysis on rational expectations models, but base the policy analysis on behavioral expectation model. And for example, the important finding I mentioned, that in positive feedback systems, we find this coordination on trend following behavior. And that leads to deviations from the rational equilibrium. That leads to bubbles and crashes. Well, if you want to do policy analysis, you should then use these behavioral models to see how policy can affect these bubbles and crashes. And you can do that in behavioral model analysis, policy scenario analysis, but also you can test these policies in the laboratory, in a new laboratory experiment where you play with the policy parameters in the experiment and see how that affects the coordination of subjects and the private sector in expectations, and how you could stabilize bubbles, for example. It's in a way a very new science. I mean, there have been developments, early developments going back to Hayek, for example. There has been this Santa Fe Institute complexity since the early 80s. And now there's a lot of new work in complex network theory. But I think the importance of complexity science and more generally behavioral science, this is becoming more and more important. So I think there is a kind of paradigm shift. It's becoming more and more important, and we are also starting to do now policy analysis using this new complexity behavioral science. So I think it's very important, and I think there will in the end be a tipping point in economics that will lead to much more focus on complexity science, complexity economics.